2.2. Hey, yeah. Derivatives on the what? Calculator, dude. Yeah. Some of y'all bought a fancy calculator over the summer, and you're like, when can we use it? Well, today's one of those days, right? Some of you don't have a calculator, and you're like, when can I borrow one of yours? Today's the day, right? We're going to be using the calculator quite a bit in the second half, in the second semester as we get closer and closer to the AP exam. But we're going to kind of slowly introduce it and use it as a tool rather than a crutch. Some people use it as a stretcher. We're going to use it as a tool. All right, so if you have one of my calculators or a pretty new calculator, you have what's called the math print. Math print is nice because the calculator will make expressions appear as they are written on a page or in a math textbook. That's kind of nice. It's very intuitive. If you have the old calculator, like a regular 83 or some 84s without the math print, by the way, I can give you the program for math print. You have the classic print, which you have to input things in the calculator programming language. So there's some parameters that you have to learn. I'm going to teach in the math print style. So if you have a classic print, just kind of come see me sometime, and I'll show you how to do it. All right, so there's two ways to find a derivative or a slope value on your calculator. You can do it from the home screen, which will allow you to find a numeric value of a derivative, and you can even graph a derivative if you do the commands that I'm going to show you in Y1. It'll sketch the graph of the derivative. Now, unfortunately, the 84 families do not give you the equation of the derivative, but you don't need the equation in order to find the graph of the derivative or the actual slope at a particular point, because the calculator, as I showed you yesterday, will compute the slope at a point using the symmetric difference quotient. And most of the time, it works, or it's so close to the actual value, you can infer what the value is. Okay, so let's start on example 1. It says evaluate each of the following on your calculator. We got f prime of 4 if f of x is the natural log of x. Now, before we do that, let's just review what the natural log of x is, right? That's going to be a function that is got a vertical asymptote here, and it's monotonic increasing. What is the x-intercept? 1. Very good. The natural log of 1 is what? 0. Okay. So we want to know what is f prime of 4. That translates into the slope of the tangent line right there at 4. Now, just looking at that, that should be a positive or a negative number? Positive number. Now, we could set up the limit definition and find it ourselves, but no, today's not that day. Today is all about the calculator. So there's two ways to do it. Let's go from the home screen. Most of the time, we're going to be doing things on the home screen. To find the derivative at 4 from the home screen, you can hit Math and then select menu option 8. Math option 8 is N derivative. That's one way to get it. I like that. And then you should get this Leibniz notation showing up. That's the derivative with respect to some variable of some function evaluated at that variable at some value. Now, there's another way to get it. If you have the new operating system, you can also hit alpha window. And alpha window brings you to this menu here, and notice it's option number 3. So it doesn't really matter if you hit Math 8 or Alpha 2, 3. I like Math 8 because it's one fewer keystrokes. All right? Now here's what you're going to put in. This first blank here is your independent variable. That's the derivative with respect to x. Now notice as soon as you type in an x there, it appears over here as an x. This vertical bar is called the when bar or the evaluation bar. It means I'm going to evaluate it at x equals. All right, now in here goes your function. For us, that's the natural log of x. So we hit ln of x, close the parentheses, click to the right, and there's our function. And now we want to find the slope at what? 4. So we'll type in a 4. Yes? What? Oh, you have the n deriv. Okay, I'll show you. You have the classic print. And you have an 84 plus. So you know what? If you bring it to me or leave it with me overnight, I can download the new math print for you, and it's a lot more intuitive. If you have an 84 or an 84 plus and it's not showing up like this, you probably don't have math print. They're upgradable. You can upgrade to the new operating system, and I'd be happy to do that. Okay, so let me show you how to do that. I'll do it once. This is Leibniz notation again. We'll be writing it like this later on. The derivative with respect to x is the natural log of x evaluated at x equals 4. That's how you would read it. You hit enter and you get 0.250000052. Now, based upon that, what do you think the actual value is of the slope of this graph at 4? You think it's actually 0.25 all those zeros? You have a 3 decimal accuracy burden or responsibility in this class, I should say. If you round or truncate, it doesn't matter. Truncate means not round. So if you went out to 3 decimals, rounded or truncated, you get 2.250, which is technically correct. But guess what the actual answer is? It is actually 0.25, which means it does simplify to 1/4. Now, how are you going to know that from your calculator? You need to learn when your calculator is trying to numerically give you a hint, because remember, it does the symmetric difference quotient, and sometimes it doesn't hit the nail perfectly on the head. If you see a string of zeros, I would say like 3, maybe even 4 or more, round down. If you see a string of 9s, 4 or more, round up. So this is 0.25 terminating. Now let me show you what it looks like in classic print. You go to classic print, it's going to look like this. If you hit Math 8, it says n derivative. Here are the parameter arguments. The first thing you type in is the function. So you're going to say the natural log of x. Close it. Now you're going to put a comma. Right above the 7, there's a comma. That separates your parameters. Comma with respect to x. That's your independent variable. That's like the first thing we typed in Leibniz form. Another comma, then you type in the value that you're interested in. So you kind of have to remember the programming language. Function, comma, x always. This is always an x if this is an x, comma, value you're interested in, and you get the same answer. Okay? All right. Is that a reasonable value for our graph now? Is it reasonable that the function goes up 1/4? Yeah, I think so. All right. How about the next one here? Notice this is Leibniz notation. We want to figure out the derivative of y with respect to x evaluated at x equals -2. That's how we write the evaluation in Leibniz form, if that's our function. Now, I don't really know what that function is. Let's go ahead and do this. Instead of typing it in on the home screen, what we're going to be doing later on in the year is we're going to be using these equations for multiple things, like parts A, B, C, and D. So sometimes it's worth going to y equals, typing in your equation once. Now, if you have the old classic print like I do, you're going to have to put parentheses around your numerator and then parentheses around your denominator. If you don't do that, it's not going to divide by the entire quantity. So that's how you would type it in classic mode. If you have the new math print, which I'll switch back to now, it's really nice because you have your horizontal division bar, which you can access by hitting alpha y equals. The very first one is numerator over denominator. Now, with the horizontal bar, you don't need to worry about the parentheses because you use the directional pad to scroll down to the bottom. So either way, there you go. You've got it. Now, if you hit zoom 6, let's just say you're curious as to what the graph looks like. You're going to have looks like a vertical asymptote at -2.5. I want to know what the slope is at -2. Now, here's a way to do it from the graphing screen. From the graphing screen, if you hit second trace, which goes to your calculate menu, second trace from the graphing screen, not the home screen, notice what is option 6? dy dx. That's Leibniz notation for the derivative. If you select 6, it is now waiting for you to type in a value. Let's type in -2. You hit enter, and here's what's nice. It gives you, if it's on the screen, it'll give you a blinking cursor and show you the visual. But if not, it shows you what it is. So it says dy dx at -2 is what? -38.00016. That's only 3 zeros, but the number after it is 1. That's relatively small. So is this one of those cases where you would infer that it's just -38? Yes. I have a different operating system. Did you type in? Did you hit second trace number 6? Now type in your number. When you hit second trace number 6, it's going to give you some garbage at the bottom, wherever it happens to be. But it is still waiting for you to type it in. There you go. Now if you type in your number, it'll tell you. There you go. You have to hit second trace. Oh, you got to do it all over. Yeah, you got to do it again. Second trace number 6. Oops, you're in the wrong menu. You got -38. So that's how you do it from the graphing screen. Now, truthfully, we're not going to be doing it from the graphing screen hardly ever, because if I need to use this number for something, I then have to write it down, store decimals. If you do it from the home screen, it's there ready to be calculated with something else. So here's what we're going to do in the future. It's just nice to know you have options. Let's say you have your function already typed into y1 and you want to find the slope at -2. I don't want to type it in again into the home screen. So let's just go to Math 8, which recalls the derivative from the home screen. We're going to take the derivative with respect to x. Now, since my function is in y1, how do we recall y1? Everyone can get it by clicking the vars button, clicking to the right to your y vars, and then hitting enter for function mode. And there's all your y's. You can also get there by going to the shortcut, which is alpha trace. Alpha trace gets you to the shortcuts, and I have our function of y1, so if you just select 1, there it is. And now we're evaluating at -2. If you have the classic print, you're going to hit Math 8. It's going to be n deriv. You'd have to recall y1 from the vars, y vars function, comma x, comma -2. Now, if you do this, it's already on the home screen. You hit enter. And so now if you needed to store that, let's say I need to use that, I'm just going to hit store as alpha A. And now I have it stored as A, and if I ever need it again, there it is with all the decimals. But in this case, we said that we're interpreting that to be -38. So we could say that this equals -38. So it's possible to do it from the graphing screen, but even if you type your equation into y1, you should still do it from the home screen. All right, do part C on your own. Part C on your own. I'm going to do it from the home screen. I'm going to do it with you. I'm going to do it in classic mode one last time. When you have the math print, as soon as you hit the caret to type in the 1/3, you don't need parentheses around the 1/3 because you're typing it in exponent land, which is nice. But you do have to hit right on the directional pad to get back down on the ground floor. If you have the classic print, you got it. You need to put your exponent in parentheses.
Just to put that, like...
No, that's good. No, it's good.
Just at 1 divided by...
As long as you're in exponent land, which you are, that's good. So the calculator tells us that the slope there is 100. Is that a big number? Is that pretty steep? Yeah, going up 100 for every one it's going over. That's pretty darn steep. So if this were a question on the test, guess what answer choice A would be? If you had a calculator and it was a multiple choice question, answer choice A would be 100. Okay, would that be the right answer? No. Oh my goodness, why not? Let's come back. Y'all remember x to the 1/3 from yesterday? X to the 1/3 is the inverse function of the cube root of x. Remember what it looks like? It's smoothly connected everywhere. But what type of tangent line exists at 1/3? A vertical tangent line. And what's the slope of a vertical line? Non-existent because it's some type of infinity. In this case, if you look at the tangent lines as we come in from the left, they're approaching positive infinity. So a vertical tangent is a place where the function is not differentiable, and that happens at 0. The calculator just told you that the slope there was what? 100. And we know that the slope there is not 100, but positive infinity. How close is 100 to infinity? Not very far. But your stupid calculator, it thinks that 100 is the same as infinity, right? How much money do you have? $100. That's like a lot. I mean, it's going to last me the rest of my life. I have like an infinite amount of dollars. It's 100. That person is like, oh, man, sorry, dude. 100 and infinity, so far apart, right? Why does the calculator think 100 is infinity? Is it living like in the Great Depression and did $100 is like having infinitely many dollars? No. No, good thought, though. Remember, your calculator computes the derivative by using the symmetric difference quotient. And it chooses a value to the left that's h units away to the left of 0, chooses a value to the right that's at h units away, and it finds the slope of that line. It just so happens that the closest points that it uses to the origin end up having a slope of 100, and that's kind of sad, right? So You have to know when to distrust your calculator. Hopefully, in the future, you don't just go to the calculator, type it in, and write down the answer, because if you would have given any forethought to the problem, you would have been like, oh, x to the 1/3. Oh, that's a parent function. That's going to have a vertical tangent at 0. What's the derivative at 0? I know it's d/e because it's infinity. And then you could check the calculator and say, ha, calculator, right? Calculator. Calculator, dude. Get out of here. Worthless. So anyway, 100 would be answer choice A on the test, and guess what answer choice E would be? D/e, and that would be the right answer. Your calculator is a tool, right? But just because you have a hammer doesn't mean you walk around hammering everything, right? If you need to, like, put a screw into a piece of wood, a hammer might work, right? But it's not what it was designed for. So just be careful. All right, so part D, which of the previous gave us correct answers and which ones didn't? Well, actually, none of them hit the nail right on the head, right? We were pretty close on A and B. We had to still infer. And then on C, the calculator was just way off, way off. Now, if your calculator ever gives you an answer that's like a whole number, well, I guess 100 was a whole number. If it gives you like a nice 3 decimal and there's no string of 9s or 0s, it should be correct to 3 decimals. All right, there's one last thing that your calculator can do for you. It can graph derivative functions. So I'm just going to do this very quickly. I want to sketch the derivative of f prime or f of x equaling negative cosine of x. And now I don't know what the derivative of negative cosine is, do you? But I'm going to let the calculator sketch the graph of the derivative, and then I'm going to recognize the lion by his paw. And I'm going to be able to figure out what the equation is of the derivative after the calculator graphs it. All right? And the way the calculator graphs it is by computing a bunch of little slopes, like it just did here, at a bunch of different points that's lined up to its pixel resolution, and it plots them and connects the dots. So here's how you graph the derivative of negative cosine. You go to y equals now, and you do the same thing, math 8. You're going to take the derivative inside the function. Now, in the math print, it's not this. This is the classic, so it's negative cosine of x, close, comma, x, comma. Now, here's the part that's important. This little comma x is going to be the math print's first x down the bottom. But the very last thing in the math print where it says x equals is what we put here. Instead of evaluating it at a specific point, like 5 or 4, we're going to let it calculate it for all x, like that. So that's how you would type it in math print. Now, what mode should you be in if you hit the cosine button? Radian mode. We are. Now, I'm going to show you how it looks in math print for those of you that are maybe still struggling. You go to y equals, and there it is. Sometimes when I type it in math print, it switches to classic and vice versa. So you'll have the derivative with respect to x of negative cosine of x, close parentheses, and evaluate it at x equals x. This is cool because it'll take every x value then in the window, calculate the slope, and plot it. Now, if you hit zoom 6, again, that's a good place to start because we're not sure what the derivative graph looks like. You get something that looks like that. Now, that is graphing kind of slowly, more slowly than it would a regular function because it's computing slopes. So this would be the derivative of negative cosine of x. Do you recognize that equation? It looks a lot like sine, doesn't it? Because it looks like it starts at the axis Sahala, right? Axis high, axis low, axis. Without changing the window, can we verify sine by just testing out a few values? I think so. Hit the trace button and now type in any value. What's sine of 0? 0. So that matches up. But what's sine of pi halves? Just type in pi divided by 2. And again, you can type directly over the numbers that are showing at the bottom once you hit trace. What should sine of pi halves be? From the unit circle. 1. Does the calculator give us 1? More or less. That's the calculator's version of 1, right? 0.99999999983. That's the calculator's version of 1. Okay, so that's pretty good. What about cosine of 3 pi halves? Let's type in 3 pi divided by 2 after we hit trace. Cosine of 3 pi halves, or sine of 3 pi halves should be what? Negative 1? Does the calculator give us its version of negative 1? Yeah, and one last one. What is sine of 2 pi? What should sine of 2 pi be? 0. Does the calculator give us 0? Hey, for once it gave us the actual right answer, right? 0. Way to go, calculator. Starting to regain my trust in you. So yes, now you know the derivative of negative cosine is what? Sine. Okay, you want to memorize that? You can if you want. I am not going to tell you don't memorize that. Because as soon as I do, you're probably going to want to do it anyway. And I can't keep you from memorizing it. If you want to, that's fine. I'm going to go ahead and write down my conclusion. It's positive sine of x. All right, I want you to do this one on your own very quickly. What is the derivative of 0.25x to the fourth? And don't cheat by setting up the limit definition and evaluating it. That would take you a long time, but you would get the right answer. Don't cheat. That would be a giant sledgehammer. It would work, but don't cheat. See if you can identify it by the derivative. So again, here's how you type it in. The derivative with respect to x, that's how we read that. The function goes here. Evaluate it at x equals. It's important to put the x there because it's going to compute it for every x in the window. Hit zoom 6. And again, it may take a little bit of time to graph simply because it's working hard. It's computing a bunch of slopes. You have yours figured out? How to type it in, the arguments? Yes. Yeah. Do you need it the rest of the day? No? Okay. Yeah. I'll install it during my conference period. Well, we're going to put y prime. We're trying to identify what the equation of the derivative is without actually calculating the derivative. Do you recognize what that's the graph of? Yeah, if you look at this, this kind of looks like a cubic, right? So maybe it's just plain old x cubed. We can evaluate it. Let's plug in like a 2. Okay, if I plug in a 2 and hit enter, what's 2 cubed? Should be 8. Let's see if the calculator knows it. Is that the calculator's version of 8? Yeah. Let's plug in a 3. What's 3 cubed? 27, or as the calculator calls it, 27.03. Close enough. All right, so there we go. I think there's enough confirmation there. What is the derivative of y equals 0.25 x to the fourth? It appears to be 1x cubed. Do you want to memorize that? You can. There's going to be a rule that we'll memorize later that will help you find that very, very quickly. Tangent does look like that, but notice I plugged in some numbers, right? So 3 cubed is 27. What's tangent of 3? Not 27. So that's how we can kind of, very good. It does look a lot like tangent. What are the odds that a fourth degree polynomial's derivative is going to be tangent? I don't know. I mean, it could exist. All right, now this one here, I'm not going to do, I think I'm going to stop right there. We're kind of done. There's one last thing that I'm going to show you, and this is what example 3 is. I'm not going to do it with example 3. But let's say I wanted to graph the derivative of the derivative. Your calculator can do 2 derivatives without knowing the equation. So if I wanted to sketch the derivative of what's in y1, watch this. In y2, I'll say math 8. I'll take the derivative with respect to x of, I'll go to alpha trace. I'll take the derivative of what's now in y1, and I'll evaluate it for all x. And this is pretty impressive because now, without an equation, it's taking the derivative of a bunch of data points that it created for the first derivative to generate the second derivative. And notice as I'm talking, it's not showing a graph, but it's still working. Work it, work it. Now, if this is x cubed, what do you think the derivative should be? If an x to the fourth derivative was x cubed, an x cubed derivative looks like it might be what? An x squared. And this is not x squared, it's actually 3x squared. Okay? So, this is cool. Your calculator can take the graph of a function and generate 2 derivatives. But it will not take a third derivative, unfortunately, without an equation. All right, that's enough. Go ahead and give your worksheet a try tonight. It'll be due tomorrow, whether it's complete or not. I'll give y'all a free participation grade for doing it. Does that make sense? All right, make sure you turn your calculator in. If you need to borrow a calculator from me overnight, you can come check one out at the end of school. Have a good day.